pre-cal students to the homework up video, page 194. Let's go ahead and take a look at these 9 graphs, okay? First of all, here's the first one we're going to look at. Notice we have a 1 up top, so we're going to put x to the 0 power right here. Okay, the first thing we do is we find the vertical asymptotes, okay? So we take the denominator, set it equal to 0, and solve. And we have a vertical asymptote at -2. So we'll come over here and put vertical asymptote at -2, okay? Now, next is the horizontal asymptote. Remember, whenever the degree in the numerator is smaller than the degree in the denominator, which is the case that we have, then we always have a horizontal asymptote at 0, okay? At 0, always. Whenever the degree up top is less than the degree in the bottom. Okay, next we're going to find the x and the y. The x and the y-intercepts, okay? So here we go. Everywhere there's an x, and there's really not an x here, we're not going to worry about that. Everywhere there's an x, we're going to put a 0. So we'll put a 0 right here. 0 plus 2 is 2, so 1/2. So we put a 0 in for x, and we got out 1/2. So the y-intercept is 1/2. Now the x-intercept, okay? The x-intercept, remember I taught you, you take the numerator and you set it equal to 0 and solve, okay? Well, students, you really can't take 1 and set it equal to 0. And if you want to use 1, x to the 0 power equals 0, that's fine. But let's review again first. So remember, when you're trying to find the x-intercept, you take the numerator and you set it equal to 0, okay? The numerator and set it equal to 0. Now, having done that, you can divide by 1. You have x to the 0 power equals 0, but x to the 0 power is 1, so you still get 1 equals 0, okay? So there's not going to be an x-intercept, okay? Let's put a check there, nothing there. Alright, now what we do is we go ahead and we put our vertical asymptotes on, so we'll have one of those at -2, alright? So there is my vertical asymptote right there at -2. Now, horizontal asymptote's at 0, so we'll go and put a horizontal asymptote here. Alright, now we have a y-intercept of 1/2, so right here we know it's going to be a point. Now with your calculator, you simply type this function into your grapher, and of course you're going to put 1 divided by, then don't forget your parentheses, x plus 2, close your parentheses, okay? And we'll go right to the table now. You always look at your vertical asymptotes. Your vertical asymptotes always tell you what numbers to plot in your table of values. So we're at -2. Let's go over to -5. At -5, we're going to be at -1/3. At -4, we're going to be at -1/2. And I didn't go over far enough, so hold on. 2, 3, 4, 5, be right here at 1/3. Then 1/2. And at -3, we're going to be at -1, okay? Now, if you get real close, let's go to 2.1, -2.1. So go to your calculations, and -2.1. And at -2.1, barely past the vertical asymptote, we're going to be way down at -10. So we're looking pretty good here, guys. The graph, we're just sketching it, looks like that right there. Now, let's come over here to our table of values, and right away, I'm going to go ahead and put in 1.9, because right before you get to this vertical asymptote, you're going to have 1.9. So I'm going to, my button is sticking on my calculator. Hold on 1 second here. Value of -1.9 would give me 10. So when I'm real close to the asymptote, I'm way up here, somewhere at 10, okay? Now going to my table of values, -1 is going to give me 1. 0 gives me 1/2. 1 gives me 0.3. So I think we can see the pattern here. It shoots way up quickly here. Hits the graph here and straightens out and goes like that. So pretty simple, okay? Alright, moving on to number 29. Alright, now your degree up top is a 1 and your degree up top is a 1, okay? Let's remember that. Okay, your vertical asymptote, we can pretty much do that in our heads. If you take the denominator, set equal to 0 and solve, you will get -1. Okay, your big pre-cal students, it's pretty easy to do. Let's go on to horizontal asymptotes. Whenever your degree in the top and bottom is the same, then your horizontal asymptote is lead coefficient. The x-intercept is always found by taking the numerator and setting it equal to 0. So you would get negative 5 divided by 2, negative 2.5. So there's your x-intercept, okay? Negative 2.5. Now, to find the y-intercept, we'll put a 0 in for x right here, and a 0 in for x right here, okay? 2 times 0 is 0. This is 0 here, so 5 plus 0, 1 plus 0. 5 over 1 is what we end up with if you put 0 in for your x's, and so your y-intercept is 5, alright? So let's quickly sketch these. Vertical asymptote of negative 1 right here. Horizontal asymptote at 2. That's perfect. Horizontal asymptote at 2. Alright. And then we have x-intercept at negative 2.5. So right here. And a y-intercept at 5. There we go. Alright, here we go. Let's go ahead and type this function into our grapher. Remember to put parentheses around the 5 plus 2x. And of course parentheses around the 1 plus x. And let's go to our table real quick. My vertical asymptote is negative 1. So I'm going to go over to negative 4. At negative 4 I have a positive 1. At negative 3 I have a 1/2. Of course here I have a half. At negative 2 I am at negative 1. Okay? Now I'm going to go ahead and type in 1.1 for a value. Negative 1.1, excuse me. And I will get negative 28. So it shoots way down here. So there's the curve. And it's going to shoot way down here. Now, I'm going to go ahead and put negative 5 in just real quick to see what I get. It's 1.25. So we're getting closer and closer to the asymptote here, but not crossing it. So there we go. Now let's go to the right of the vertical asymptote. So we have numbers. Let's go ahead and put negative 0.9 in. Let's get real close to that asymptote real quick here. So negative 0.9 gives you out 32. So at negative 0.9 we're way up here, okay? Then using your table of values, at 0 we are at 5. At 1 we are at 3.5. At 2 we are just at 3. And at 3, 2.75, 4, 2.6, and it's getting gradually lower and lower, approaching that horizontal asymptote, okay? And this one's going to shoot way up high quickly. Alright, there we go. Moving on to number 33. Alright, now once again, notice we have the same degree in the top and the bottom. So once again, we can pretty much do this in our head, students. The vertical asymptotes are going to be, this will be interesting. I better do this for you to show you. X squared plus 9 equals 0. Bring the 9 over and make it negative. Take the square root of both sides, and you get 3i. Because the square root of negative 9, make that positive and put an I, then plus minus, and the square root of 9 is 3. So there's only imaginary vertical asymptotes. In other words, there are no vertical asymptotes. So what are we going to do? How are we going to know what x values to put in? Well, let's worry about that later, okay? Right now, we'll just put none. Now, horizontal asymptote, we've learned that when the degree up top is the same as the bottom, 2 and 2, then the horizontal asymptote is lead coefficient over lead coefficient. So 1 over 1. So we have a horizontal asymptote at 1. Now the x-intercept. Okay, the x-intercept is when you take the numerator and set it equal to 0 and solve, and you do get 0. Okay? Now, the y-intercept is when you put a 0 everywhere there's an x. So we'll put a 0 here and a 0 here. Okay? Well, 0 squared is 0. 0 squared plus 9 is 9. 0 over 9 is just 0. Okay? So we really don't have a lot of information, to be honest with you. We know we have a vertical asymptote at 1. Okay? We know that. And we know we have some intercepts here. But that's basically about it. Okay? So an x-intercept of 0. So here's my recommendation. I would get your, first of all, I would type into your calculator this function. So go ahead and type in x squared divided by, and then parentheses around, x squared plus 9. Okay, now go to your table. I would encourage you just to use your table and just go like -5 to +5 and just see if that gives you a good idea of what the graph is. Like -5, 1, 2, 3. -5 is 0.7. -4 is about 0.64. -3 is a half. -2 is 0.3, so a little lower. -1 is 0.1, so it's way down here. Okay? And then 0 is 0. I think it starts to go back up again. Okay? Just like this. Yeah, it does. Just like this. So the graph's going to come down. It's going to be getting closer and closer to the horizontal asymptote. It's going to come down, hit here, and then smoothly go back up, and then continue on. It's like that. So it's like an amazingly flat parabola. Okay? But you know, if there's no vertical asymptotes, and you really, the vertical asymptotes, as you guys know, really help you know which numbers to put into, to look at on your table of values in your calculator. When you don't have that, just kind of improvise and just look at the values of the table. Look at the values on your table of values and try to figure out a pretty good idea of what the graph looks like. All right, number 37. We have degree 1, degree 2. Well, first of all, your vertical asymptote is going to be non-existent once again, okay? Because s squared plus 1 equals 0. Bring the 1 over, make it -1. Take the square root of both sides, and you're going to get nothing. Now, the horizontal asymptote is going to be 0. Okay? Because the degree up top is smaller than the degree in the denominator, so you have a horizontal asymptote of 0. Now, the x-intercept is going to be 0. And the y-intercept will be the same thing. Now, the x-intercept was 0 because we took the numerator and set it equal to 0. Okay? The y-intercept is 0 because everywhere there's an x, I put a 0 or an s. So you get 0 over 1, which is 0. So again, not a lot of information to go on, okay? Let's get our horizontal line up here. Horizontal line at 0. There we go. And we have x-intercept of 0. So right away we can see that our horizontal asymptote is going to be crossed, okay? But that's okay. That happens sometimes. We know that, okay? All right, let's go ahead and go to our calculators and type this in. So we have x, or s, whatever you want to call it, divided by parentheses, x squared plus 1. All right? And let's go to our table and see what we come up with, okay? Yep, looks like pretty much the same thing. I'm going to go all the way to -5. And -5 is -0.2. -4 is -0.23. -3 is -0.3. Then we have -0.4. And then 1 is -1/2. And then it tends to go like this. Curve away. Then come back up and hit this. Then over here, if you plot these points, it's going to hit here, and then at 1. So the horizontal, listen students, the horizontal asymptote does get obeyed a little bit, and it is a help, because you can see it's getting closer and closer to the horizontal asymptote here, and it's never going to cross it, but it does down here cross it, and it comes up to 1. At 1, we are at 0.5, so a half, okay? And then 2, we go back down to 0.4, and then so on and so forth, then 0.2, then 0.2, 0.19. So it's going to come up, hit here, and then start circling back down again, okay? And getting closer and closer to the horizontal asymptote. So the horizontal asymptote does help a little bit, but it also gets crossed, okay? Alright, number 41. Alright, so here we go, students. First of all, we have to find our vertical asymptote. So we take our denominator, set it equal to 0, and solve. If you factored the denominator, you would get x minus 2x plus 1. I'm not being mean, but by now we should really be able to factor those quickly, okay? -2 is the a number that makes this parentheses 0, or positive 2. Negative 1 is a number that makes this parentheses 0. So our vertical asymptotes are at negative, positive 2, and negative 1. Now, let's find our horizontal asymptotes. Well, it's very obviously at 0. Whenever the degree in the numerator is smaller than the degree in the denominator, you have a horizontal asymptote at 0. Now let's talk about the x-intercept. The x-intercept is going to be 0 because you take the numerator, set it equal to 0, and solve. The y-intercept is also going to be 0 because everywhere there's an x, you put a 0. So we have 0 squared minus 0 minus 2, which gives you a negative 2. And 3 times 0 right here is 0. So 0 over negative 2 is going to be 0. Now, pretty much, again, just the same thing over and over, okay? So we have 2 vertical asymptotes to put up here. And let's quickly line those up. One vertical asymptote is at positive 2. So there we go. And the other vertical asymptote is at negative 1. So right here, alright? Now we have a horizontal asymptote at 0. So put that here and slide that down to 0. There we go. Alright, so there's our vertical asymptotes. Now, we have, let's see here, an x-intercept of 0 and a y-intercept of 0, so we can see the horizontal asymptote does get crossed. Okay, now with your grapher, go ahead and type in the numerator 3x, then divide it by, then be sure and put parentheses around your x squared minus x minus 2. Alright? And so let's start with our negative 1 vertical asymptote. Let's go to 2, 3, 4, maybe negative 5. Let's see. At negative 5, we're at negative 0.5. 2, 3, 4, 5, so about right here. And then at negative 4, we're at negative 0.6, so a little lower. And then at negative 3, we're at negative 0.9. Then at negative 2 would be negative 1.5. I'm going to go ahead and type in negative 1.1 into my calculations. And I'm going to get negative 10. So it shoots way down. Okay, so the graph is getting closer and closer to the vertical asymptote. And it's also getting closer and closer to the horizontal asymptote. Now, here in the middle, let's go ahead and plot. Well, I'll tell you what, let's get real close to this asymptote on the right side. That's negative 0.9. So negative 0.9 gives me out 9. So I know I'm way up here somewhere, okay? Then at 0, I'm at 0. At positive 1, I'm going to be at negative 1.5 right here. Now let's get real close to the asymptote. 1 to 1.9. At 1.9, we're going to be at negative 19 way down here. So the graph's going to come down. It's going to hit here. It's going to continue to smoothly go over here and then continue to shoot down like this. And again, we're just sketching it, okay? Good enough. Now, over here, let's put in 1, 2, 3, 4, 5, and 6. So let's go back to our table and let's go to 3. 3 is going to be at 2.25. And then 4 is going to be at 1.2. 5 will give us 0.8. 6 will give us 0.6. Now let's barely go past the asymptote. 2.1. So calculations. 2.1 is 20. Way up here at 20, okay? So there we go. Getting closer and closer to the horizontal asymptote and the vertical asymptote. Alright, very good. We're cruising right along. Let's take a look at number 45. Alright, number 45. Alright, now if this helps, I'm going to go ahead and put an x to the 0 power here. Okay? Now the vertical asymptotes, we have none. Okay? If you take the denominator and set it equal to 0, you'll get plus minus I, so no vertical asymptotes. The horizontal asymptote will be at 0, okay? because the numerator degree is smaller than the denominator. Now your x-intercept is when you take the numerator and set it equal to 0. Okay, that's not going to happen. Alright. And then the y-intercept, everywhere there's a 0, I'm going to put an x. So 0 squared plus 1 is 1, 4 is up top. So the the y-intercept will be 4. So I have a horizontal asymptote at 0. Y-intercept of 4. That's all I know. So here we go. Let's break out our graphers again, and let's use them like we should. Let's type in 4 divided by, then parentheses, x squared, or t squared, whatever you want to call it, plus 1. Alright, let's go to our table right away. Now, I'm looking here, and I'm seeing a pattern, for the most part, like negative 5 is 0.2. So negative 5 is 0.2. Negative 4 is also 0.2 or 0.23. Negative 3 is 0.4, so a little higher. Negative 2 is 0.8, so a little higher. And negative 1 goes up to 2. Alright, then we know it's going to hit here. Alright, now if you continue on, 1 is at 2, and the pattern continues to repeat. If you look at your grapher, here we're going to be here, and then here, and then here, and then here. So the graph's going to look like this. Then the graph will get closer and closer to the right, to the horizontal asymptote, and to the left, to the horizontal asymptote, okay? So really not too difficult. Alright, number 49. Now here's where it's going to get a little tricky, okay? So let's be really careful on this. Now, first of all, students, I'm sure, in fact, I'm sure, I know that there's a way to graph this, in which you would graph this, and then this, and get a picture of them, and then take each ordered pair from each graph and subtract them, and get the new graph. Excuse me for yawning. That would be amazingly difficult to do. You would first graph this, that's a lot of work, then graph this, it's a lot of work. So let's just pretend one graph looks like this, and one graph looks like this, okay, or something like that. Then you take ordered pairs, and you subtract them, and get the new graph. That's crazy. So we're going to do something obviously a little different. We're just going to very calmly get a common denominator. So I'm going to take my denominator here and multiply it by x. So I have x squared plus 1 times x. Now if you multiply the bottom by x, you must also multiply the top by x. Now, over here I'm going to take x and multiply it by this denominator. So x squared plus 1. However, if you take x and multiply it by x squared plus 1, you must also multiply 1 by x squared plus 1. Well, 1 times anything is just itself. 1 times x squared plus 1 is x squared plus 1. Now combine these two fractions because you do have a common denominator. Your common denominator is x, parentheses, x squared plus 1. So combine them. 20x squared minus x squared plus 1 is going to be 19x squared plus 1. Okay, so that's when I combine these two fractions, I get this. So there's no need to keep this around, and there's no need to keep this around because we're now going to graph this. Okay. Alright, so with that in mind, here we go. Let's find the vertical asymptotes. Well, if you take the denominator and set it equal to 0, you will have vertical asymptotes at 0 because you would have x squared plus 1 equals 0. So it's already factored for you. 0 makes this group 0. And then here, there are no zeros. You get plus minus 1i. So there's no zeros for this parentheses, okay? So my vertical asymptotes are going to be at 0. Now my horizontal asymptote, be careful please students, your degree up top is 2. If you take this x and multiply it through, you get x cubed plus x. So your degree down here is a 3. So your degree in the numerator is smaller than your degree in the denominator. So you have a horizontal asymptote at 0. Now your x-intercept would be, take the numerator and set it equal to 0 and solve, and you would get nothing. So there's not 1. Okay? You had 19x squared. I'm going to go really fast. Plus 1 equals 0. Bring the 1 over and make it negative. So 19x squared equals negative 1. Now divide by 19. X squared equals negative 1/19. You cannot take the square root of a negative number. So there are no x-intercepts. Okay? Now the y-intercept, of course, we're going to put a 0 everywhere there's an x. And we'll see what we come up with. Okay? So we'll put a 0 here. A 0 here. So 0 plus 1 is 1, and 1 times 0 is 0. Put a 0 here, you get 1 over 0, that's undefined, so there's not going to be a y-intercept either, okay? So we're going to look at none. Alright, now, which does make sense, students, because we're supposed to have a vertical asymptote at 0, so that does make sense. Okay, vertical asymptote at 0, and a horizontal asymptote at 0. So let's slide this over. There's one of my asymptotes. Here's my other asymptote right here. And we're going to make these a little thicker so we can see them a little better. And there we go. Okay. Now we have no x or y intercepts, so we're really ready to get on our graphers and start putting in numbers. Okay. So y equals, clear out your old functions, and we're going to type in our new one, parentheses 19x squared plus 1, close your parentheses, divided by, and then parentheses, I'm going to put x cubed, is what I'm going to put, x cubed minus or plus x. I think that'd be the best way to do it, and then close your parentheses. So for my denominator in my grapher, I just put x cubed plus x. I took the x and I multiplied it through. I think that'd be the best way to type it into your grapher, okay? Now, let's go ahead and go to our tables here, and let's go way over here to negative 5, and let's see what we have. Negative 5 is negative 3.7, 1, 2, 3.7 down here. Alright, and then negative 4 is going to be negative 4.5, so going down a little further. And then we're going to go to negative 5.7. Then negative 7.7, so way down here. Negative 2 will be way down here somewhere. And then negative 1 is going to be at negative 10. Now, I can't put that on here, okay? Maybe I should try to slide this up. I think it's important because this graph is going to do something that you guys don't know about that's a little interesting, okay? So please watch this carefully. Now, so at negative 1, I'm down here somewhere at negative 10. Now let's get real close to the asymptote, okay? So we're going to put in negative 0.1. And you're going to expect to get out, let's see, negative 0.1. Is going to give you a negative 11, which will be a little further down, okay? Now I thought this graph took a sharp turn going up, and maybe I should try another value of negative 0.01 just to see what happens, just for the fun of it. No, it continues going down. Okay, that's fine. So, here's our graph going down. Now, let's go to the right of our asymptote. Let's put into our calculator 0.1. Alright, 0.1 gives me out 11, so I'm way up here somewhere. And now we'll go to our table, and let's see, 1 is at 10, and then 2 is at 7.7. Right here. And then 3 is at 5.7. 4 is 4.5. And then 5 is 3.7. So that should be way up. This point here should be way up here somewhere. So just ignore that. And it's going to hit like the other graph is. And it's going to eventually just kind of bottom out like this, okay? Alright, moving on to the next one, number 53, okay? Alright, now first of all, we're going to start off with our vertical asymptotes. If you take the denominator, set it equal to 0 and solve, you'll have a vertical asymptote at 0. Next, there are no horizontal asymptotes because the top is not, the degree in the numerator is not smaller than the bottom, and their degrees are not the same. Now what we do have is a slant asymptote. The degree in the numerator is exactly 1 more than the denominator. So in order to find the slant asymptote, I've got to use long division, alright? So here we go. X goes into X that many times. X times X squared is X times X squared. And then change your signs and bring down your next term 1. X goes into 1 0 times, so your remainder is going to be 1. Okay, so what you end up with here is just X. So your slant asymptote is going to be at Y equals X. Okay, alright, go back and watch that again if you need to. Moving on, let's go to your X-intercept. X-intercept. Let's see. There's none. Okay, none. If you took the numerator and set it equal to 0, you would get plus minus 1i. Now the Y-intercept would be none. Okay, because if you put a 0 in for X squared, you get 1 up top. Put a 0 in for X, you get a 0. You can never have 0 in the denominator, so it's undefined. So we have a vertical asymptote at 0, okay? So let's go ahead and quickly draw that. A vertical asymptote at 0, so there we go. And then we have a slant asymptote at Y equals X, alright? Let's see if we can put that. Y equals X means 1, 1, 2, 2, 3, 3. There we go, perfect. So there's the slant asymptote. I hope you guys see that okay. 1, 1, 2, 2, 3, 3, 4, 4, over 5 up 5, so on and so forth, okay? Y equals X. Now, we have no X-intercepts, no Y-intercepts, so we are totally ready now for our grapher. So let's go to our Y equals, clear out your last equation, X squared plus 1, in parentheses, divided by X. Then go to your table of values. And let's see what we have, okay? First of all, my vertical asymptote is here. So let's go over to about negative 5 approximately. Negative 5 is negative 5.2. So about right here. Now, negative 4 is like negative 4.25. So barely. That's why I told you guys it's so important to graph your slant asymptotes correctly. At negative 3, we're at negative 3.3. At negative 2, we're at negative 2.5, so it's breaking away a little bit. At negative 1, we're at negative 2. Alright, now get real close to your vertical asymptote. I'm going to go with negative 0.1. And I'm going to get negative 10, so it shoots way down here. So the graph is going to look like this, getting closer and closer to the slant asymptote, and pretty soon it's going to turn, and then it's going to go down and get closer and closer to the vertical asymptote. And it's probably going to do the same thing in here also, I can only assume. So let's see, let's work our way now to the right of the vertical asymptote. So let's go to 0.1, okay, 0.1, and let's see if we can't get a value out for that. 0.1 is positive 10.1. So I know I'm way up here somewhere, okay? Now, with my table of values, let's see, 1 is at 2. 2 is at 2.5. 3 is at 3.3, just like the other one, so barely there. 4 is at 4.25, same thing again. So it's the same thing, folks. It's getting closer and closer to the slant asymptote. And it's going to hit here and kind of curve, and then it's going to take off and start getting closer and closer to the vertical asymptote up here also, okay? So there you go. Alright, moving on to our last one, and we're finally finished. First of all, we have a vertical asymptote at positive 1. If you take the denominator and set it equal to 0 and solve, you will have a vertical, you will see that you will get 1, so a vertical asymptote at 1. There's no horizontal asymptote, however there is a slant asymptote, okay? So let's grab this real quick, and let's drag this to the next page over, and let's go ahead and we'll bring it back in just a second. We're going to go ahead and use long division and have a lot of space here. So x minus 1 divided into x squared minus x plus 1. X goes to the x squared, x times. Take your x and multiply it. Change your signs. These all cancel. Bring down your positive 1. X will not go into 1. Your degree here is 0, which is smaller than this, so you're finished. This is your remainder here. So really you have y equals x again, so same thing that we had before. For the slant asymptote, y equals x. Alright, let's bring it back over here. So a slant asymptote at y equals x, okay? Now the x-intercept is when you set the numerator equal to 0 and solve, and you cannot solve that, students, if you take this. First of all, you can't factor it. Second of all, from what I can see, and let me quickly, sorry for yawning, let me quickly make sure this is right with my calculator, but I'm pretty sure if you use the quadratic formula on that to solve it, you would get out, yes, you would get out imaginary numbers. So there's nothing that makes this numerator become 0. So the x-intercept is none. If you tried to solve that, you would see it cannot be solved. Go ahead and use the quadratic formula, and you'll get out imaginary numbers. Now the y-intercept, let's see, everywhere there's a 0, we're going to put or x put a 0. So up top, we're left with the 1, negative 1 the bottom. So 1 over negative 1 is negative 1. So we have a y-intercept at negative 1. Alright, so with that in mind, let's see, we have a vertical asymptote at 1, okay, and we have a slant asymptote at y equals x again. So there we go. Alright, let's go ahead and put this at positive 1 where it's supposed to go, and let's make sure this lines up with 1, 1, 2, 2, 0, 0. Yes, that's perfect, okay? So we should pretty much get the same graph again, which is a little redundant, but it's good practice. Okay, no x-intercepts. Your y-intercept is negative 1, which should be right here, okay? So don't forget that, okay? Using my table of values. Well, first of all, yeah, my table of values. My vertical asymptote is at 1, so I'm going to go 0, 1, 2, 3. I'm going to go over to about negative 4, I believe. And negative 4, 1, 1, 2, 3, 4. We're way up at 21. I mean, it's long gone. Negative 3 is 13. That's a little better. About right up here. Negative 2 is 7, okay? So, 1, 2, 3, 4, 5, 6, 7. And then negative 1 is 3. 0 is here. Now that's, okay, we're probably going to have two different parts. Okay, I see now. Okay, so let's get real close. Let's first put in this number here. So it's going to come down and hit here. Alright, now, okay, students, back at you, and I'm sure I've totally frustrated you there. Sorry about that. I did not have the correct and let this be a lesson to you guys. Your old teacher did this, but I forgot to type this into my grapher. That's a pretty big mistake, so I've typed that in. Now let's see if we get out some different values, okay? So let's go over 1, 2, 3, 4. So at negative 4, I'm at negative 4.2, which is below the line. At negative 3, negative 3.25. And at negative 2, negative 2.3, negative 1 is negative 1.5. And then we hit here. Now let's go barely to the left of this vertical asymptote. That would be 0.9. So calculate 0.9 gives you negative 9.1. So it shoots way down here. So again, students, a little redundant, but it's good practice for you guys. This would hit here and then circle around and come shooting way down here. Okay? But it's good that you're learning how to graph these. Now, let's go ahead and move on to our table of values. Let's go to the right of our vertical asymptote. So now we're going to be at 2, and 2 gives me a 3, and then 3 is a 3.5, and then 4 is a 4.3, and 5 is a 5.25. So right there, we're getting closer and closer. Okay, it's getting closer and closer. And then let's put in 1.1 just to see what happens. And we're going to hit 11.1. Just going to shoot way up here somewhere, okay? So there we go. Just get a little sketch of it. It doesn't have to be perfect. Just kind of see what the graph's doing, okay? So there you go. We did it. Complete the assignment. I hope that you guys are really understanding how to graph these rational functions. I hope this video has been a help to you. If you have any questions, don't hesitate.